Now let us look at this question, and it says, now a binary operation asterisk is defined over R, which is a real number, by x asterisk y equals xy plus x raised to the power of 2 plus y raised to the power of 2 for all x, y, which are elements of R. Now determine, you say, 1, whether or not the operation asterisk is commutative, and 2, if x asterisk into bracket, in bracket rather, x plus 2 equals 49, find x. Now let us start. Now for commutative property, x asterisk y must be equals to y asterisk x. Now this is for commutative what? Property. Now let us see if this property is the same. So it implies that even though we interchange it, it should give you the same what? Effect. So now for this operation here, you have what? X operation y, now which gives us xy, now plus x raised to the power of 2 plus what? Y raised to the power of 2. Now let us now interchange y asterisk x, which means wherever you see x, put it for y, and wherever you see y, you put for x. So in this case, you have what? Yx, then plus y raised to the power of 2, then plus x raised to the power of 2. Now let us see if this and this has the same effect. Now since we are having product here, it can also be interchanged. So it means that the operation is actually what? Commutative, because the effect we have for x operation, x asterisk y asterisk x is the same as x asterisk what? Y. Now let us tackle the next one. Let's not say x operation that x plus 2 then equals what? 49. Now first of all, here we have x, then the operation here we have x plus what? 2. Now it implies here, now take note that for it's same thing as saying x y, right, which gives xy plus x squared plus what? Y squared. So it implies that wherever we see y, we replace it with what? X plus what? 2. And wherever you see x, we have what? X. So in this case now, here we have x asterisk x plus 2. We now give here, the first one here is x times y, which is what? X, then into x plus 2, right? Then plus, now x squared, here you have x squared, then plus y squared, which means x plus 2 all squared. Okay, now let's open the bracket. Here we have x squared plus what? 2x, okay, plus x squared, then plus, if I were to open this bracket here, or rather expand it, where we have x squared plus 2x plus 2x plus what? 4. Okay, so here we have x squared. Okay, let's collect like 10. We have x squared there, x squared there, x squared there. So we have making 3x squared. Then here we have 2x plus 2x plus 2x. That will be 6x. Then plus 4. Now take note that the whole of this operation gives you what? 49. So that will be equal to what? 49. Okay, so let's bring 49 over to the left hand side. So here you have 3x squared plus 6x plus 4 minus 49, all equals what? 0. So here you have 3x squared plus 6x. Here you should have 45 plus 45, all equals what? 0. I guess 3 can go through in all. So let us divide through by 3. We are left with x squared plus 2x, now plus it should give us 15, all equals what? So I guess we arrive at a factorial a quadratic equation which we need to what? To factorize. So how then do you factorize this? Now what will you multiply to give you 15 and you add to give you plus 2, okay, and that should give you 5 and 2. 5 and 3. 5 and 3. But I guess, oh sorry, here you have minus, here you have minus. I thought as much. Alright, so we should be having 5, I guess, and 3. Okay, so here you have x squared now plus 5x minus 3x minus 15 all equals what? 0. So then x you factor out, you have plus 5 minus 3x plus 5 all equals to 0. So here you have x minus 3 equals 0, x plus 5 equals 0. So x equals 3, or x equals what? Negative 5. Alright, this is the solution to the question. Thank you and God bless you.